For 3, we just have to pick the inequality that's true when x is negative 3. So I'm just going to do each one. Alright, so when x is negative 3, so the opposite of x, if x is negative 3, that would make it 3 minus 6 smaller than negative 3.5. 3 minus 6 is negative 3. Negative 3 is not smaller than negative 3.5. It's greater, so A does not work. Let's look at B. Okay, the opposite of x would be 3 again. Minus 6 is greater than negative 3.5. 3 minus 6, as we discussed, is negative 3. Negative 3 on the number line. We'll prove it right here. Okay, 0. Here's negative 1, 2, and 3, and 4. Negative 4, right? Negative 3. Here's negative 3. Here's negative 3.5. Right? So negative 3 is actually greater than negative 3.5. So that is true. That is true. Which inequality? It says it's singular there, so I'm not even going to check the others. The others are not true. Oh, it does say, I'm sorry, it says positive 3.5 there, so scratch that. Scratch that. If that was a positive 3.5, no. But the next one does say negative, so it is that one. I'm sorry. I was solving C, so C is the one that we want there. Negative 3 minus 6 is not bigger than negative 3.5. That'd be negative 9, and it wouldn't work. So C is the one we want there. Sorry about that. Number 4, we have to draw the solution sets for these. So when x is smaller, less than or equal to 5, so we put a dot on our 5, and since there is a line underneath of it, we fill in our dots, and we want all of the numbers that are smaller, so that would be everything in this direction shaded. So there's our solution set. Some people do the shade, some people do the arrow, everything over here, same thing. Okay, so last one on number 4 here, part B. 5 is smaller than 5 halves. Well, 5 halves is equivalent to 5 cut in half, which is 2.5. You can divide that out or just do it mentally. 2.5 is right here. Okay, so there it is. There's our dot. It needs to remain open because it is no line underneath. And it says less, so that would be every number over here to this side, less than 5 halves. And lastly, a year ago, Claire was 4'6". Now she's 4'10". So percent change. We're looking at a double number line here real fast. So a little review. Never bad to go back and understand how to do these. Can do a little conversion on this one too. Okay, so was 4'6". So that was her 100%, what it used to be. It was the old Claire when she was only 4'6". Now 4 foot is equivalent to 4 times 12. So I'm drawing crazy things on here. Let me undo that. Sorry. 4 foot is 48 inches because of your multiplication facts times 12. And if you add another 6 to that, that is 54. So she used to be 54 inches, but now she is 4'10", which is 4 inches taller. That would put her at 58. The question is, what percentage is she at now, and how much was that an increase before? So we can cross multiply and divide from our table here. 58 times 100, cross multiply these, and then divide by 54, and that puts us at 107.4%. So 107.4%. What was her percent increase? From 100 to 107.4, we're going to say about 7.4% increase. That is our jump in height. Not bad. And that is lesson 14 finished.